Welcome to my channel. This is the integral that is 0 to 1 x to the power x and dx. Okay, this is variable to real variable. So see, this is can be expressed as 0 to 1, and like x to the power x is equal to e to the power ln x to the power x, and this equal to e to the power x log x ln x. Okay, x ln is e to the power is e. So x to the power x, in place of that we can write here x ln x dx, and the extension of e to the power x like that. Okay, and that is equal to, we can write 0 to 1 as 1 plus x ln x by factorial 1 x ln x by factorial 2, and this is whole square, and x ln x whole cube factorial 3 and dot dot. Okay, and dx here. Okay, sorry. Now let us assume my integral, that is j is equal to, this is to the power 1, this is to the power 2. That's why let us assume x ln x to the power n by 1, 2, 3 like that. This is factorial n and dx here. Okay, and this is here 0 to 1. And now let us assume that is 0 to 1 x to the power n plus ln x to the power n by factorial n in dx. Let minus ln x is equal to as a p. So ln x is equal to minus p, implies that x is equal to e to the power minus p. Differentiate, then we get e to, dx is equal to minus e to the power minus p dx dp. Okay, and now see the limit here. If x is 0, if we put 0 here, then we get p tends to infinity. Okay, the upper limit be here 1. If we put 1, log 1 is 0. So this is here 0. So now x is equal to, that is e to the power minus p, e to the power minus p to the power n here, and ln x is equal to, that is here minus p to the power n, and dx is equal to minus e to the power minus p and dp, and this is equal to, this is a 0 to infinity to 0, there was a minus, so change the limit here like 0 to infinity. Okay, and now here this is here. Okay, this is here dx dp. Okay, this is dp. Okay, in place of x is this, in place of log x is this here, and in place of dx is minus e to minus p dp. Okay, now here that is minus 1 whole to the power n. Okay, and now the addition of 2 power e to the power minus np, and this is here minus p, again p to the power n, p to the power n and dp. We can write here minus 1 whole to the power n that is 0 to infinity e to the power minus Pn plus 1 into p to the power n and dp. Let minus p into, this is the power e to the power p into n plus 1 as a y. Define set dy minus n plus 1 into dp implies that dp is equal to minus, okay, this is plus, this is here need to be minus, so the gamma function, so and dy, so this is equal to minus 1 whole to the power n. If we let us assume as a y, if the value of p put here 0, then we get 0 here. If we put here infinity, then we get infinity here. So limit is unchanged here. So this is equal to minus y. And now p. P means y by, that is 1 whole to the power n. And dp. dp is equal to 1 by n to the power n plus 1 and dy. And this is minus 1 whole to the power n. And see that the n plus 1 to the power n are n plus 1. So their addition be here n plus 1 to the power n plus 1. And now again see 0 to the power 0 to infinity, it will be minus y, and this is here y to the power n and dy. See carefully, minus 1 whole to the power n. Okay, n plus 1 whole to the power n plus 1, and it will be minus y to the power n and dy. Okay, and from the definition of gamma function, this is plus 1 and this is minus 1 and dy. So minus 1 whole to the power n, and this is n plus 1 whole to the power n plus 1, and this is equal to gamma n plus 1. And this is equal to minus 1 whole to the power n by n plus 1, and this is factorial n. Okay, this is the formation of that. Okay, there was a mistake here. This is here factorial n also, 1 by factorial n. Okay, this is a by factorial n. Okay, this is by factorial n here, this is by factorial n here, and this here also factorial n, this is a factorial n, this is a by factorial n. So these two factorial n are cancelled, and the value of this integral is here minus 1 whole to the power n by n plus 1 whole to the power n plus 1. Okay, now this is let us assume as a I, and this also I here. Okay, and now see for the first term, that is I is equal to 0 to 1 dx, and this is a 0 to 1 x ln x by factorial 1 and dx. So this is a 0 to 1 x ln x whole square by factorial 2 dx, and again 0 to 1 x ln x whole to the cube by factorial 3 dx here. Okay, and so on. And dx is x, that is 0 to 1, so this is 1. And for this is to the power 1 by factorial 1. So similarly, if 1 by factorial 1, the value of n here is 1. So value of n here is 1. So if we put here 1, then we got there, here, this is to the power 1 by 1 plus 1, this is 2 to the power 2 here. Okay, this is 2 to the power 2 here. And here, minus 1 whole square by This is here 1, so that's why 2. If you had 2, then 2 plus 1, this is 3, factorial 3. No, this is 3 to the power 3. This is 3 to the power 3. Okay, this is B1. When this is 1, so 1, this is 2, 2. Okay. And for the this is at 2, n equal to 2, n equal to 2. So n equal to 2, 2 plus 1, 3. Okay, this is 3 here. And now fill cube. This is minus 1 whole cube, and this is 3 plus 1, 4. This is 4 to the power 4 here. Okay? And this is the answer of the required integral. And we can arrange this formation. We can arrange here, okay, as a summation, that is here n equal to 0 to infinity, that is minus 1 whole to the power n by n plus 1 whole to the power n plus 1. Okay, see, if we put 0, then we got this and 1. Okay, if we put 1 here, 1, 2 to the power 2, if we put here 2, then 3. Okay, this is the answer. Okay, so this is the answer of integral 0 to 1 x to the power x dx, that is summation 0 to infinity minus 1 whole to the power n and n plus 1 whole to the power n plus 1 and dx, summation 0 to infinity minus 1 whole to the power n by n plus 1 whole to the power n plus 1. Okay.